necessarily a tradition yet, but hey, we've got an extra Echo in the office and I want to take it apart. I found this cool tutorial on iFixit. Let me show you. Where they actually did a teardown already, but it's not a video, so this will be fun. Plus, I mean, it's a lot less fun for me if I just read the thing. But I wanted to share with you how cool their teardowns are to start with. There's a lot of stuff that I would not know off the top of my head, or they did all this research and stuff to figure out what all the different chips do. So if you get curious about any of the stuff that you're seeing in here, you can ask me, but you can also take a look at the iFixit Amazon Echo teardown, and that will probably answer some of your questions better than I can. However, I'm going to take a Q&A at the end, so any questions that you write in the comments in the meantime on Facebook, I'm going to be able to answer. Okay, enough talking, more breaking. Okay, so first off, I think they started from the bottom. And on the bottom, well, first off, we've got this charger that plugs in. And what does it give it? 15 volts at 1.4 amps. That's really interesting, actually. Okay. Well, it's powering a couple of pretty beefy speakers. One of the coolest things about the Echo, actually, from the teardown that I saw, was how much thought they put into the sound arrangement on here. And so this is not only a teardown, it is also me preparing to ideally replace the brain of the Echo with something of my own making. That assumes that I have the ability to put it back together again, but I've got a fair amount of practice with that, so I'm not too worried about it. I don't have all the like single-purpose spudger tools that they do, but I think I can use my screwdriver to get this apart. There's just like a little rubber foot on the bottom. You just yank off there. It comes off pretty easily. Yeah, it's got the model number and all the stuff about how it complies with the FCC rules and how it's assembled in China. So here on the bottom, we've got this fun little set of contacts or something. I'm not sure exactly what that is, but we're going to be taking this apart. There's some hex screws on here, and at this point I'm actually going to zoom out a bit, I think, if I can do that without you seeing too messy of my desk. Let's see. Oh no! That should give us a little bit more working room. And let's change the focus on here too. It's pretty good. All right. Pulling out my marvelous screwdriver set. I love this. And I just sort of took a moment to organize it before I started this. So we're going to be using a couple of Torx screwdrivers. There's the, I think the T9 and T10 are what they're using. So let's pull those out. And this is just a generic set called Comkia is the company that makes it. I've also got an amazing set from iFixit, but I leave those at home because they're my nice ones. Yeah, sweet, nice fit. Oy. This piece all comes off in one, which is why I'm not starting with the ones that are sort of topmost. Come on. We're slipping a little bit, but hopefully this is working okay. Ho ho! Look at that screw. So, oh, that's kind of stripping. I wonder if I use a slightly larger one. Hopefully this won't be just a really short teardown in which we strip all the screws and can't get them out. There are ways to fix that, but they are a pain in the bum. Come on. I'll try going really slowly. Oh boy. Huh. Well, let's try a couple of these other ones and come back to that. Yeah, so one of the things with tearing this down is that I want to try putting my own voice assistant in it, like maybe a Mycroft one or Google Home running on a Raspberry Pi or something like that. These are really reluctant to come out of here. If you can see, the screw heads themselves are not particularly well defined, they don't have these nice, deep, grabby bits that my screwdriver does. So they're actually being a bit of a jerk. Well, that was unforeseen. Curses. But have no fear, I have some other cool stuff to show you, even if this doesn't work out, although I'm going to keep trying to make it go. Yeah, so, you know, I want to put my own brain inside of here, and it turns out that this is a totally legitimate technique for prototyping. Even some big companies that produce products for, you know, big box stores and whatnot, all the stuff that you buy off of the shelf, may get its start as, a works like looks like, which is why some companies have started hiring makers to produce sample designs before they go through a whole huge production run or invest energy and time and money into tooling. And for example, getting, you know, exactly the right batteries with exactly the right specifications and efficiency and everything for the application, just to get an idea of what it's going to be like. They're having makers like put together like 12 samples where normally they'd only be able to produce one, and then the clients can take a look at those and see which they like the best before any more time and money is committed into the project. Oh my, these are really not wanting to cooperate. Oh, that's so frustrating. So far, I would give the rebuildability of this thing pretty much a 2 out of 500. I mean, okay, we got one of the screws out, but like, one of the key things about the hackability of a product is your ability to take it apart and put it back together again. I'm going to keep jamming on this, but in the meantime, let's take a look at some of the internet stuff. You can still look at the iFixit tutorial, which still has a ton of cool information. And one thing that I liked about it was that they link you, for example, to the description of a speaker driver. So the Echo has inside of it this huge tube that basically reverberates and helps redirect bass frequencies so that it sort of amplifies them, which is really cool. And I learned a ton about audio technology just from going down a Wikipedia hole after this, after reading this before. If you haven't checked out iFixit, totally do it. But there's all this cool audio technology research that went into the Echo. And you can see they've got a tweeter in there, they've got a woofer, and the woofer itself has a damper back here, and the reflex tube is shown down here, which they say it looks like a saxophone. So most reflex tubes in bass cabinets, as far as I'm aware, are usually just a straight tube. However, this one's all curled up and stuff so that it can fit inside the Echo and still provide a good response. Presumably the length has something to do with the frequencies in particular that it helps support. And that's how you get really nice sound out of it. In fact, the only reason that I use an Echo in the office is to listen to music. And it's great because it can kind of like act independently from my computer and stuff. Another cool thing about the design of the Echo is the little MEMS microphones in it. If you're not familiar with MEMS, it's another cool Wikipedia hole to go down. So it stands for Microelectric Mechanical Systems, or Microelectromechanical Systems, or whatever. And it's basically a teeny tiny components that have microscopic moving parts. And in this case, there's a membrane inside of each teeny tiny little microphone that vibrates. Now let me show you what this looks like on a different device, because I happen to have with me the Matrix Creator, which is basically a large build-your-own Echo thingy. It's got a ton of LEDs around the edge to give you feedback. It's based on an Atmel chip, and it connects to a Raspberry Pi over here. And then what do you got here? You've got a bunch of MEMS microphones. 1, 2, 3, 4, 5, 6, 7, 8 around the edges. Super cool, and you'll be able to recognize these often because they have a kind of gold color, and sometimes they have a little hole in them. So these are what a microphone will kind of look like when you have it on a commercial PCB. And yeah, you can, this is one of the things, actually, its smaller version, the Matrix Voice, is what I was thinking of putting inside the Echo, because it kind of fits. Might need a little work. Or, you know, any other thing that I could put inside of here, like a regular Pi or a Pi Zero W. And both of these have these MEMS microphones. Okay, let's have a look at that again. So basically, as this page explains, it's on EDN network, edn.com. Basically, they deposit all these different layers of material onto a silicon wafer, and then they etch away the material that isn't needed, and that creates the movable membrane. And in this case, oh yeah, the sensor backplate is a stiff perforated structure that allows air to move easily through it. And obviously, you know, if there were no airflow, then nothing would be able to vibrate really, and you wouldn't have a microphone. And the membrane itself is a thin, solid structure that flexes in response to the change in air pressure caused by sound waves. Now, when I read this, I was thinking this is probably a piezoelectric device. Like most, there are some like flex sensors that work that way and whatnot, but it turns out that the changes in air pressure cause it to flex, while the thicker black backplate remains stationary, and what it works on is the change in the amount of capacitance between the membrane and the backplate, which is a function of their distance between each other. So as the membrane vibrates, it changes the capacitance between it and the rest of the microphone, and that translates into an electrical signal. That's interesting to me because it contrasts with the way that most piezoelectric speakers or pickups work. I mean, also speakers. This is another type of audio pickup that's sometimes used in microphones that I've played with extensively in the past. And it's really cool too. A piezoelectric disc is made of a crystal, for example, of quartz, that when it's squished and compressed, it gives off an electrical voltage. Just a very tiny one, but it's sensible. It can be sensed. So they sandwich that between metal plates, and then you attach one plate to the ground wire and the other one to your, you know, voltage or detector analog in, and that way you can pick up the electrical pulses that are created when it vibrates. And for example, you can just stick a piezoelectric disc onto a guitar or whatever, and you'll have a kind of crappy pickup. You can even use them as really kind of terrible speakers. So if you see a piezo buzzer or speaker, that is using electrical impulses to drive sound. So just like if you compress it or flex it, it gives off electricity. The opposite is also true. If you apply a voltage pulse to it, then it will vibrate, which is really cool. So we kind of went down a hole on microphones here. Again, the Echo itself uses these MEMS microphones, which I think are fascinating because they're microscopic mechanical systems that are super duper tiny, but somehow magically work. I did want to show you more about these Matrix devices, and so now I guess I have a whole rest of the show to show you. I am going to try and get this thing open, by the way, just not right now because I don't have the tools or the patience with me. It would take kind of a while. But as a consolation prize, let's look at these. Let's look at these creator thingies. Yeah, as I mentioned, they can be attached to a Raspberry Pi. I've actually done a whole video on the Matrix Voice itself, which I'll link underneath this one. It's currently set up, it's got an ESP32 device on it, which not only connects it to the internet, boop, boop, boop. I can't resist. Not only connects it to the internet, but also can run the entire device. So you program this one using a Raspberry Pi, and that basically talks to the ESP32 and programs it to respond. So this thing doesn't even need a Pi connected to it, which is super cool. And it's got fewer LEDs. I think there's 24 on here or something like that. Supposing we cut this in half, then we get, wait, 9, 18? 18 LEDs, something like that. And 1, 2, 3, 4, 5, 6, 7, 8 MEMS microphones on here. One is in the middle, and then there's 7 around the edge. Plus an audio out. One of the cool things about this is that unlike the Echo, it has an audio out, so you can use whatever kind of or speakers that you want. And I want to pull up that page. So Matrix Creator. And you can get this on Newark. But you can also get the Matrix Voice, which is the smaller one. And of course, there's a Hackster page for each of these. Super cool. Okay, so I wanted to also talk about how I would go about creating my own assistant that would live inside of the Echo. So this thing, right? It's got some really sweet speakers, but it also has a bunch of circuitry inside of it to drive those speakers. And I'm guessing that I wouldn't just be able to hook up, you know, an audio out to those speakers and have it work very well. Because a lot of that, you know, there's special types of amplifiers and whatnot. So while we're here, let's learn about the LM386 a little bit. This is if you get a beginner maker kit that has an assortment of chips in it, chances are you're going to get a 555 timer, which can be used to generate electronic signals, really basic music, like you can do 8-bit music with it, waveforms, and obviously just for timing stuff as well. And then also this LM386 chip, which is a low-power audio amplifier. Actually, the first project that I ever built in a hackerspace, which is where I learned a lot of my electronic skills. I did not study this in college. I mean, I was a first kid in high school, first robotics. But yeah, the first hackerspace project I ever built was Make's Crackerbox Amp project, which is a low-cost amplifier with a bunch of, you know, pretty readily available parts. And this was the amplifier chip that they used in it. And the whole thing runs off of a 9-volt battery. So this is 15 volts. That thing is 9 volts. You know, you can have it, you can run these things on 5 volts. You don't have to have a super weird power source or a ton of power in order to run any of these things. Yeah, so that's the LM386. Check that out if you're into audio technology. And on the subject of the like looks like works like, as I mentioned, a lot of companies are, if they're smart, sort of turning to more of these sort of just-in-time, produce a bunch of prototypes for cheap. You can use 3D printers, you can take apart things that already exist. For example, if you want to make like a luxury device, you can just take a cheapo device and wrap it in wood veneer or leather or whatever. You can also go the other way around and do and take an existing enclosure. This is not actually the first Amazon device that we've torn down. I took apart an Amazon Dash button and turned it into a device that helps you enter a really creative state of mind using principles that have been exploited by, for example, Dali and Edgar Allan Poe and whatnot. So check that out if you're curious. I'm really a fan of learning by taking stuff apart and just replacing its insides or learning all about how it's put together. And I think that that iFixit is like a great site for that. And also on the subject of the Echo, we have contests open for you to submit your own hacks using the Amazon Echo or other Alexa devices. Oh, it's not responding. I actually still have one in the office that's sitting right there, sort of watching in horror as I dissect its sibling unsuccessfully. And yeah, so there's a 3D imaging contest using the Wallabot device, which kind of sees through your walls magically and can tell if there's wooden studs or metal pipes or whatever in the way. We've also just wrapped up a couple of ones with Alexa. There's the Alexa and Arduino Smart Home Challenge. This one is really great to check out if you have an Echo and you don't know what to do with it. Look at all the winners from this one. They've got super cool ideas and tutorials up. Just go and click on the Projects tab. all kinds of cool stuff. And I think that the judging, the prizes are going to be announced in just a few days here, I believe on the 12th. So, but in the meantime, you know, you don't have to subscribe to somebody else's arbitrary grading system. We actually have a very sophisticated grading system. But anyway, you can judge for yourself which of these are going to be the coolest. And yeah, go check out the Matrix Creator and the Matrix Voice Board. If you're interested in building your own smart assistant from scratch, this is a great place to go. And there's also, you can check out Mycroft is a smart assistant that you can install on the Raspberry Pi or whatever. All kinds of other cool stuff out there. Thank you for, if you stuck around through this crazy ride. I hope that you have enjoyed this no matter, I mean, you know. So the teardown failed for now. We're going to come back to it once I get these frickin' screws out. But I think that there's some pretty cool stuff in here anyway. We will be back. And I'll be back tomorrow with the Wednesday, some kind of cool, weird information. I think I'm going to talk about Charlie plexing LEDs, which is a really cool method by which you can control a large number of LEDs with a small number of GPIO pins on your controller. In fact, to be precise, you can control, for example, if you have 8 pins, you can control, I think, 56 LEDs, which is 8 times 7, it's 8 times 8 minus 1, which is your general formula, n squared minus n. LEDs can be controlled with n pins. It's really fascinating. So if you don't want to watch the show tomorrow, and just go look it up on Wikipedia now, but even so, you can come back and have fun with us. I'm going to check and see if there's any questions, even though we didn't get through the teardown, but then we're going to sign off. Oh, there's a lot of comments. Oh my goodness. Use a torch. I'm not going to use a torch on this right now. Maybe I'll use a Dremel after I wrap this up. That might actually be a good way to do this, but I'm not going to do it on the air right now. Oh, maybe we'll do that tomorrow, though. Cool. Use a hammer for precision. I will not, but thank you, Mohib. Alright, thanks for watching. Have an awesome rest of your Teardown Tuesday. Tear down something in my honor, please, because I want to see something break. It's gonna be cool. Alright, have a great rest of your Tuesday, and we'll see you tomorrow. Ciao.